Hey everybody, Dr. Phil here. Here with another video for you on measurement foundations as it applies to research. So, first thing I want to talk about is levels of measurement. Because if you're going to be a researcher, it's very important that you understand these four levels. Okay, so the four levels are nominal, ordinal, interval, and ratio. So nominal speaks to, and I'm going to elaborate on each of these in future subsequent slides, but just to kind of give you a bit of a primer, nominal basically think of like a name. So like if something is going to be named, it's going to be what? It's going to be classified. Okay. So nominal scales are mutually exclusive. What that means is if you're this, you're not that. So for example, you're either a freshman or a sophomore, right? You're not both. So they're collectively exhaustive categories. And it's just a classification, right? It doesn't necessarily, I mean, in some cases it might, but in a lot of cases it doesn't mean anything more than it just being a simple classification system. Um, so as an example, so if we look at religious preferences, mapping rule A versus mapping rule B. So, number one is Baptist, number two is Catholic, and then number three is Protestant, but then if you look at mapping rule B, right, you notice that they're different. So the point they're trying to make here is that you may have two different systems that, number one doesn't mean the same thing in both systems, right? Here we see that mapping rule A, number one is Baptist, mapping rule B, number one, of course, is Christian. Now let's talk about ordinal. So, easy way to think about ordinal is just think about what that word ordinal sounds like, and that's order. So, we're going to try to put some things into a type of order. So, the nominal scale characteristics is, of course, we're going to order things, and then it implies a sort of a greater than or less than. So the example here they're trying to give you with a steak is think about, when you go to a restaurant, if you go to like a steakhouse or you just order, a steak at a restaurant and they say, how do you want it cooked? You might say rare, medium, medium well, well done, etc. Um, you could also use the example I gave you earlier, which is, if you think about the levels of college, right? Freshman, sophomore, junior, and senior. So those would also be ordinal scales. Next is interval. So there's a classification order, but what's different here is because you might look at ordinal and you might look at interval and say, I don't really doesn't seem to be any difference between the two. There is a subtle difference, and that is that there's a distance, there's like an equal distance between each of the classifications. So if you think about the example they're giving you here, you notice they've got a little thermometer here. So we've got the Celsius, and then on the outside we've got Fahrenheit on the inside, as you can see. But and regardless of which scale we're using, Celsius or here Fahrenheit, um, the difference between like 0 degree and 1 degree Fahrenheit is the same as the difference, the space, the space, if you will, between one and two, and then two and three, and then three and four. They represent an equal sort of partition, if you will, equal amount of space. As it says, there's an equality. Another way you could say that equality of interval, or you could say equality of distance between numbers. And then finally, the ratio. So the ratio is kind of like the highest and most complex one, if you will. And here we have a distance, but we also have a natural origin. So I'll kind of explain that a little more here. The idea of the ratio is that there is an absolute zero. So, for example, if you think about like in this example, they're putting a baby on scales. If there's nothing on the scales, then the scale reads zero, and there is an absence of weight, right? There is no weight on there at all. Whereas if you think about the thermometer example, the temperature, if you look at if you look at your phone or you look at a thermometer or whatever, and it says it's 0 degrees Celsius, then that still implies temperature, right? That's still a temperature, a cold one, albeit, but that 0 degrees Celsius or even 0 degrees Fahrenheit does not imply a lack of temperature, right? Whereas the ratio scale does, because if there's nothing on the scales, then there is no weight. So characteristics of good measurements. So certainly validity, reliability, and practicality. So I'm going to talk about practicality first. If you come up with a measurement, but it's very impractical, then as part of like your sort of like research design, it may be very hard to kind of pull that off. Reliability in the sense that if you're measuring something, you should be able to measure that same thing again and get the same measurement, right? If you keep getting different measurements, then it's not very reliable. Validity really speaks to is okay, so is what you're measuring actually helping you with the experiment? Because if you're measuring the wrong thing, maybe it's very reliable and maybe it's very practical, but if it's not measuring what you need it to measure to advance sort of further your experiment, then the measurement lacks validity. So validity determinants really have three. We have content validity, we have construct validity, and we have what we call criterion validity. So judging criterion validity. So what we're looking for here is relevance. Again, the criterion should be relevant to whatever it is we're studying. Again, it should be reliable. We should be able to measure it again and repeatedly and get the same measurements. It should be available to measure. If it's something that's very hard to get, then that may be a problem. One example of that would be, again, I do a lot of research, publish a lot of papers, and if I want to say get secondary data, then I'll typically try to do that from publicly traded firms because it's so much more difficult to get financial data, particularly in my case, and in my purview, if you will, from non-public companies because they often don't want to disclose it. If they do, they might want to charge you for it. It may take longer to get. Um, and then the last thing would be freedom from bias. You want to make sure that the criterion is in no way biased because, of course, if the criterion is biased, then guess what? The odds are your results will also be biased, right? And that's not what you want. You want to make sure that your criterion, again, is reliable, make sure it's relevant to what you're doing, make sure it's free from bias, and make sure it's available. So here we see a summary of validity estimates. So we have the content, the degree to which the content of the items adequately represents the universe of all relevant items under study. And the methods here could be judgmental or perhaps a panel evaluation with content validity ratio. If we're talking about criterion related validity, the one above was content validity. So now we're talking about criterion related validity. This is the degree to which the predictor is adequate in capturing the relevant aspects of the criterion. And the methods, again, they can be concurrent. For concurrent validity, description of the present criterion data are available at the same time as predictor scores. The methods here would be typically correlational. Predictive validity speaks to the prediction of the future. Criterion data are measured after the passage of time. Again, that's correlational. And then finally, construct validity. This answers the question, what accounts for the variance in the measure? Attempts to identify the underlying constructs being measured and determine how well the test represents it. And the methods here could be judgmental, could be a correlation of the proposed test with an established one, could be convergent discriminant techniques, could be factor analysis, it could be a multi-trait, multi-method analysis. So again, there's a lot of different validity types. There's different ways to measure those, not all of which are mentioned here. And then the methods by which we would seek to do so. Again, concurrency, correlational, multi-trait, etc. I mentioned as well. And then a summary of reliability estimates. So test retest, that's a very common one. So it speaks to a stability coefficient. So what is measured is the reliability of a test or instrument inferred from examinee scores. Same test is administered twice to same subjects over an interval of less than 6 months. So this would be a correlational type method. Good example of that would be a pre and a post test that you take at the beginning and ending of a class. For parallel forms, the coefficient here would be equivalence, and it speaks to the degree to which alternative forms of the same measure produce same or similar results, administered simultaneously or with a delay. Inter-rater estimates of the similarity of judges' observations or scores, and again, that would be a correlational method. And then we get into probably some terms you haven't heard, like split half reliability, KR20 reliability, Cronbach's. Cronbach's alpha is just basically a reliability metric, if you will. And this speaks to the coefficient of internal consistency. What we're measuring here is the degree to which the instrument items are homogeneous, basically the same, and reflect the same underlying constructs. All right, thanks for watching this short video, and I will see you all in a future video. Take care.